Hello again, this is Steve Penelby. Welcome, this is Steve's Long Stay Workshop, not Long Stay Vintage Workshop. And today we're looking at this. This is a wartime, British wartime radio receiver. The one that was made by all the manufacturers from 1943-44 onwards, when supplies were getting a bit thin. And they work extremely well. A lot about, but this one is, I'd rather, a rough life. Things we can sort out include things like that, the front there, the label there. The switch, well, that can be put back on the back as usual. The cabinet can be polished or brought back, but it should be. But on the top, the sticker is still there. Now with these sets manufactured by all the best manufacturers in Britain at the time, you can tell from the chassis number at the back which. This I think is a U4, which is Marconi-form version. Everyone did them basically, and they sold on the cheap, but they weren't actually all that cheap really, but they were different. Designed by Frank Murphy of Murphy Electronics, and they came in and did when valves couldn't be gotten, things like that, very cheaply. This is the British version. The German version, by the way, I will not look at because I don't support Nazis in any way, shape or form, so I don't look at those, so don't ask, okay? Well, the British one is different, because of course it is British, and of course it is actually a much better radio as well. Medium wave only this one, although you can get them with long wave on. You also get a battery version as well. This is the mains version. The battery version is in fact fairly rare. I've not seen one. If anybody has and they've got one to sell, do let me know. But this is the British version, and it uses octo valves. Turn it round. There we are. That's the back. There's the back. I'll go back a bit so you can see. There you are. Right. See, it's these sets from this era using octo valves. These are a mixture of Bullard and Melter, because they came with various valves in them. A 500 valve, a 5 watt valve rectifier and metal on 6.3 watts. Certain things which I have to take off or hide somehow. But it looks all complete. So that's something again in its favour. The cable, well, we'll have to change. Not of it actually, but it's not exactly what I would call brilliant. As you can see there. So let's get inside and have a look and find out how and why things are doing what they're doing, or not doing what they're not doing. Okay. I notice there's no screws at the bottom. They've all been taken off, which means therefore that this set will probably come off with these two knobs on the front here. Wearing my glasses, getting old, you see. So with that in mind, just take out these knobs here, and hopefully it'll come out and we can look and find out what the score is with it under the chassis. These sets, by the way, are formed of what's called a short superhet. A short superhet, or a short superhet, the short version of the standard superhet down radio of the time. Superhets, short superhets, generally speaking, most people say that they don't perform as well, they would say the standard, the long superhet, but I've had them work extremely well, including these. They have a nice tone, and they generally perform rather well. So let's try and get this one back to its previous, probably quite excellent performance. but I'm not going to plug this one in, despite the fact that some people say I tend to do that. Yes, I do, but there's reasons why somebody can and somebody can't. So you know, this one I think in this situation is one which I do not want to plug straight into the mains. Not yet, anyway. But in the future, probably I would. So we'll get a cabinet, put the cabinet out of the way, and have a look first of all at the radio itself and see what is going on with it. Standard dead spiders there. Yeah, looks okay. Not bad woodworm or anything. So this one doesn't need to go up to J's like that radiogram of Andrews did. So yeah, it's okay, so that will come out. So I'll leave that. I don't know whether that on there is genuine or not. That's worrying. No, it's not. The valve top is missing. That's okay, but I think we'll live with that. ECC 35 or thereabouts. EF, probably an EF this one. I just check. And of course the standard EL34 or whatever that's the equivalent is, or the American version, the American equivalent is. This is it doesn't say actually, but I think it's probably something like an EF something or other. I will get the yeah, I will get the we can check on things like that. But yeah, and also with this, by the way, that's disconnected. That's disconnected. Okay, that's come off. That we can source or replace. That needs that some of the does need some work, obviously. It certainly needs painting or something along those lines. This big has to come out as well, because I want this cabinet out of the way for now. So I get the out of the cabinet and we'll have a good look at it. So what have we got here? We've got a 3-valve pulse rectifier short superheat, as I said earlier. That will have to come out. That will definitely be faulty, no messing. That proves that something has been here before any set long past, which is reasonably enough, you know. They have to come. The caps on this, by the way, one of the spinning caps does not go to deck, because these generate an extra voltage as well, so one goes to that as well. Otherwise, thing will hum like heck and not saying very good. As far as the diode is concerned, there's a device in here called a West Tector, which does the same thing. If it goes faulty, change it with, say, ordinary silicon, ordinary medium diode. It'll be fine. Say 0891, something like that. No problem there. Nice change of capacitors he needed, obviously, you know. This is faulty here, but again we can sort that. The transformer looks okay. This thing on the back here, I don't know if you can see it or not, that's true. That was there because the switch used to be on the back here. So now it's time to get the circuit and have a look before we say what we're going to go and what we're going to do with this this radio. Sit down at the back and no talking, please. Time to look at this this circuit in general. So I used to be comfortably good, then I'll begin. This, by the way, is traded 688, the Wartime Civilian Receiver. This is the main circuit. Now, the brain side of it is transformer driven, as we know, and those three valves are at 6.3 volts. That one is at 5 volts. That is a UU5, so hope it's okay. If it's not, by the way, there's two things you can do with any set of this kind. One, of course, is to take the base off that and put another valve in its place. You know, that takes 5 volts. You can fit a bridge rectifier if you want, with a suitable resistor as well. Or if there's enough coming out of these two pins here, which are for the 3.3 volts, you can fit a 6X5 in as well. If you disconnect the 5, that's if that 5 isn't working. You can do that also if it has to be transformer. Any set of this kind, of course, uses a 5 volt rail. But check for the voltage as well, because of course these are directly heated cathodes. They're directly heated. So the cathode also carries the H2 as well. Things like the 625, H5, it doesn't. So that's the main difference there. Now, smoothing capacitors. Right. Well, this is the interesting bit on these. There are 3 smoothing capacitors here. 2 on the 8 put there, like that. Let's go up here. And there's one also which goes to the centre pin of C2, the H2. The H2 on these goes to the valve anodes here, and to that valve. And the cathodes, sorry, I'll tell that again. Sorry, my fault. The anodes here go to the 8 pins either side of the H2 winding, the transformer, and in the middle of it there's another winding comes out the middle there, here you see here, and what that does is it generates the voltages for the AGC as well, and also the and also here for the diode here. That's the CCT. That does not go to deck, it goes to that there. So what tape for that I'm wanting to locate for C16 on this diagram, C16. Now this part of it here, it's okay, but always change this capacitor here. Now these capacitors here, by the way, there's no HT on this here. There's no stage, amplifier stage before the pentode. Just a diode here, which, as I said, is a West Texas and can be replaced with, say, 0891. From there back, it's as is before. Okay. Now the area on this, by the way, if it's got 2 pins, it's got a local one and a distant one. What I do is link to here, and link a lot of wire to the distant one and put it out if necessary, if need be. And of course, earth goes to deck into earth like that. It's a simple circuit, but watch out for this lot here, because there are things which should be there but aren't on a short circuit of any kind. It's a very simple radio, but it does have 1 or 2 pitfalls, including, of course, that there. So something which I have to look for. That pin there is held to deck by R13 as well. As I said, these sets were used by lots of different manufacturers. Some use Brimmer valves, some Cossa, and so on, as you can see there. Mostly can swap them, mostly. this is a U4A, and so that's second winding coupling here isn't on this set. Okay, so it's always look through, find out which one it is, and what differences there are. That's something which again can make you feel a bit as though being caught out there, but you haven't really. It does happen. That's it really. This on-off switch is not on the back of these. I've got a switch to go on there. That's not a problem. So that's how the thing basically works. Now another thing, this capacitor, these capacitors, these don't leave them in. Do not leave them in under any circumstances, because if you do, they tend to go bang. So remove. Okay. So there's only one real place for these capacitors, and it's file 13. There you go. So they're out of the way now, and these two here might be faulty as well. So with a set this old, I would replace these on site. Okay. Replace these on site. Even before you plug it in, replace these on site. At this point, therefore, now, the valves in this set, by the way, are, just for the record, that's come off there, so I'll take that off there and put that back on in a minute. The first valve, valve 1, is a valve. Yeah, it's usually something like ECH35 or something along those lines. This is a is it going to tell us? So I don't know. I think it's probably going to be, look at the circuit, I think it's probably going to be something like a 6K 3G. It's either that or ECH35 or X61M or OM10, but mostly it's either a 6KG or an ECH35. That's that one. The next one along, valve 2, is usually either an EF39 or a 6K7G, but not always, or a BP262 has been used as well. This is doesn't say on this one. It said BVH347, but it doesn't say. So again, I'm going to assume that it's an EF39 in disguise. And finally, the last one of the bunch is this one here, which is the 8-volt valve, and I hope it's okay because they're not cheap. So we take that off the top and have a look and see what it is. BVA265, which it again doesn't say. I think that is probably going to be a 6G or the EL33 will do there. So that's the valves out. Okay, so those are secure. That needs to put back on there. Now this is the rectifier here, which has 5 volts. Now at this point, therefore, now we can probably what I'll do is I'll power this and make sure the 5 volts, the 6.3, and the HT are all and the HT AC are all here. That's the first thing we'll do. That will prove that transformer is okay. If it's not, we've got a problem running around because I've not got one. Here now we've got a meter on AC connected up to the HT AC side. So when I press that that meter should rise up and read about 400 and 500 volts or so. Which that looks a bit 4.5 volts. That's not right. It's not right. Let's check and make sure I've got the right. Yes, I have. Okay, fine. So that's not terribly good, is it? I'll put that back onto there properly like that and try again. Now, 4.5 of it. What we'll do here, I'm going to check that on another meter, because 450 volts would be okay. 4.53 obviously is not. So so next thing we do is check and make sure that that is the correct reading. So we get another meter and try that again. Why do I doing this? Well, the thing is that with these sort of things, if you're not sure, then test your test equipment as well. Always test that and make sure. The reason why I'm doing this a second time is because there might be another issue here, and I want to make sure that we are measuring what we say we're measuring. So that one goes into there like that. Well, the cog goes into, as you see, that goes into there. That goes into there. Like that. We'll try again. Right, yeah, that's I see it is a 5 volt. I read the diagram wrong. I admit I read the diagram wrong. I admit. Here's the diagram. You see there, and if you look underneath there, you see that that is 5 volts. That's okay. Okay, so up we go again, and we take these out and put them in these two like that, and here there should be about 500 volts. Overloads this meter. Okay, well, in that case we'll go back to the other one. Yeah, even I make, after all this time, even I make mistakes. I've been in this job for I'm 54 now, and I've been in this job 50 years. Yeah, I started very, very young. So now we'll try that again. That's about right. Okay, so we know that's okay. So we know that side of the transformer is fine. Now the other thing we need to check, of course, is a 6.3 volt rail, which is probably going to be absolutely fine. But we'll check and make sure while we're here. .4 offload, that's fine. So we find out from that now the transformer is okay. Another thing we'll check, although it's easy to replace, is the 8-foot transformer, which is here. Turn the speaker over like that and go between these two pins here. So I'll put the crocodile clip back on here. Like that. Let it onto there. That goes up like that again. Goes to ohms, of course. Or like that, and we'll see what we get. Okay, I'll go to ohms instead. sometimes of course it's the connection itself that's a problem. So there's something there anyway. Another thing we can do here, by the way, is we can check with the rectifier in circuit whether it's going to deck okay, but I think from that the transformer, that transformer is okay. So now, right, now we look at changing capacitors, which I've got actually, so we can do that relatively easily. Now I've got the old capacitors out. By the way, the size of them is amazing. That is another 8 meg condenser or capacitor, as we say today, and there's 2 of them, and of course that thing which I threw in the bin earlier on. These, I can't bother testing these, they're going to be crap. So there you go, in the bin out of the way. Now this one, by the way, was the earth pin as well, but compared to them, the new capacitors, and these are axials by the way, which are quite rare these days, are relatively thin. That is 10 microfarads at 400 volts, and that is the earth capacitor on these there. The difference is quite amazing, because the earth capacitor on these is, check on the circuit, see which one it is, C2. That's 0.005. Yeah, 0.005 actually, believe it or not, that one. So yeah, the difference is amazing, isn't it? So that one can leave us as well. So now we've got to sort out which one is which here. We do this, there are various ways of doing it. One is to switch it on and see where the power comes out, and not recommended. And so coming out from here, there are 3 wires to make us from to this hole here in the circuit. And the red one goes to 2 or 3 different valve bases. That's obviously going to be the LT for the valve heater, so you know it's not that one, okay. Now this one here in the middle, this one goes to resistor 13 and resistor 8. So that one is probably going to be the HT negative rail that discussed earlier on goes to there. So therefore this capacitor here, this one of them goes to earth through that rather than straight to the chassis here. Okay, that's one of them sorted out. Okay, now the other one here is this one here. Now this goes to pin number, check here, I think it's 14. Goes to C14. Yeah. So that probably goes to capacitor number 17 or 18. Okay. So therefore this wire here is likely to be the one which goes to the chassis. So therefore if I was to maybe bear that one, which I'm going to have to do obviously, that is one, but under here there is another one that goes to the other end of that capacitor and that there. So that is probably going to be another point where they go to. So that's the three. You can check it if you want, but first of all, there to deck goes to R13, and R13 should be something like 220 ohms. So from there to deck, it should be about 220 ohms. That'll do. That'll do. So that is the AC negative. Okay. Now, with these capacitors out of circuit completely now, yeah, that one goes to earth. It doesn't actually, but it goes via R14. Look at the circuit here, you see again. Look at the circuit there again, you see. It's R14 is that one right there. And that should be, going to diagram, 1K. So therefore, between there and here, there should be 1K. At this stage, therefore, we've got a lot of wires and we know more or less where they go. This here is R14. So from there to there, it should be something like, yeah, I don't know, 1.2K. I think this one then. Maybe we should find out where it is there. Okay, so 1.2K. Okay, fine. Now, therefore, the other half of it goes to another capacitor, which is not in yet, and then of course R15. Now R15, according to the diagram, is 2.2. So there to there, it should be. That's gone up in value quite a bit, because to there to there to there, 0, and to there, yeah. So that resistor needs to be changed, obviously. So obviously both will need to be changed there as well. So that's our next port of call, I think. So get the power supply working. Remember, PAIR, power supply, audio, IFRF, going through the set. Okay. And so now we've got to put in capacitors and of course a couple of resistors as well. I think it might work with them as they are. I don't know, but certainly R15 needs to be looked at or changed. Right, here we have the new capacitors have been installed, and the off switch is in there. It's good to be put on the back there, but for now I'll put a link across there where it goes. Okay, that's there. Okay, that's this way here. So if we plug it in now, we should get voltages across various points in here like before. So let's find out, shall we? These will all be AC. So I'll start with the 6.3 volts, which is here. So, and it goes like that, you see, and this will come up straight away. It will be more, of course, because the system's not loaded down, but we should get something, and we do. Okay, so that's okay. Now over here, therefore, we should get something, yeah, and should be at 5 volts or lower. Which is there, bright as well. That's a bit more less actually. A little bit bothered about that. Never mind. What we'll do therefore is put this in, I hope, for a reasonable outcome, shall we say. So in it goes. rectifier valve with lights on straight away, as you can see there. Nice and bright actually, that, isn't it? And so now there should be something respect to chassis. Oops, what was that? Something cracked then. Don't smell anything burning. So now there should be something. Should be something now on some pins down here. So what do we get down here on DC? Now, first of all, there should be something here. Alright, I can see smoke, I can see smoke, I can see smoke. I could see smoke. Right, okay, so wonder where that comes from. Just pull that out again and see if it's still smoked now. I get back on there, and it's reads okay, that still, so the transformer I think should be okay, but obviously something somewhere isn't, so I go underneath and take a quick look so we find out why it's so decided to let off a bit of the magic stuff. Where did that come from? It might be just heat burning off, I don't know. So what I'll do, I will put the valve in again, like this, and watch it like a hawk. What did concern me though was a crackle from the speaker, because the speaker should not be connected to anything at this point, so yeah. Where's that valve? It's there. Right, okay, so that valve goes back in there, and we'll see what it does or doesn't do, as the case may be. That goes back in, that goes there, that goes away from there, and go. And that comes back onto there, thank you very much. There we go. So let's have a watch and see where it's coming from, shall we? Yes, I know I'm holding the shot. Ah, something flashed. You see it? Something flashed. Can't smell anything though. Bit of smoke, but bit of smoke, but I don't know quite what it is or isn't. You know. Right, where's my probes? That goes into there, and that goes onto here. That's okay, but still that's smoke, isn't there? Smoke, by the way, often means the problem. It might be that valve socket looks a bit carbonised down there, so I'll scrape that and come back to you. Get the air as clean as I can. Maybe that'll stop when the valve is in and taking current, I don't know, but if not, then that socket will have to be changed. I don't know at this point about that right now. But while I'm here, I thought I'll have a quick look at power supply and where that's going. Okay, so switch to the home range, and there you are. That's all to that, and it should be something at 1.2 or something similar to that. That is with the 1.2k resistor in there, and of course the 8-put transformer, so that's okay. That one, by the way, the HT line, that's 4.3. Again, it's a bit high, but I've got to change that capacitor when the replacement resistor there, when the part comes in, so that's not urgent, but there you go. Now, with that in mind, we can also check here now the primaries of these two coils here, and we do that by putting that now onto let's see, putting that onto there like that, and that should read out to there. It does, or thereabouts, yeah. And there it goes to there, which is the IF valve, which is so that's okay as well, not 0.72. Now over here, therefore, there should be voltage up, should be something on there. Which does appear to be, and also should be something on there, which is so. We know that half of those are okay. Now the other half, all we need to do is go onto the ohmmeter again, maybe the bleeper, and go from there to, I don't know, that's okay, yeah, okay. And the other one, of course, we go from say there. I think it will be. Hang on. We go from there to there, and let's see what that reads. It does. Okay. So we know that the IFTs are passing current anyway in both, so that's another worry out of the way. Again, IFTs on these, you can change them, they come out, and you can look at them and change them, but I'd really rather not. Also, while I'm here, by the way, to deck, there'll be 600 ohms or 600 ohms from the cathode of the pentode here down to deck. So let's have a look and see if there is. It's about, I think it's that pin there. And you can see there, that too is about right. So therefore, I think I shall whip that one off for safety's and legality's sake. There we go. That can go, and that can. I don't know where that goes. I really don't know where that goes. I'll just let it hang in mid-air for now. Not the best way, but you know, it'll do for now. Okay, so I'm going to try it again with the valve, and hopefully we shouldn't get any fireworks. Now have it switched on, sort of here. That valve is in and getting warm and working away. That valve too is in and getting warm, or should do. So let's see what happens. See, straight away that's up. The HT is up because I checked it. There's no hum anywhere, I've noticed, which is but there's that. You see? So there's something coming through the volume control, which is nice to know. And so what I might do at this stage is that's that one, okay, and the other one in here is the other one, which is this one here, which goes into here like that. We know that the IFTs are okay, so that goes onto there like that. Yeah. This goes onto here like that. That goes into there like that. There we go. Now let's see if anything feels like working. With the wire off dead there, everything, I don't know what's going to happen here, but something will. I hope. Something will. Doing something. Not that off. Let's try again. Nothing. Okay. So it's obviously doing something. Okay, right, well next thing we do is we put that a wire from the top of there to there, the top cap, and put an aerial on and see what it does, or says it's going to do or not do. At this stage now, all the valves are in. The grid of the frequency changer valve is linked to the tuning capacitor here, and I've also given it an aerial basically at the meter like that. So let's see what happens now when we give it some power. The rectifier comes straight up, as you can see, and so the rest. I can see them lighting up underneath here now. So it should have, but so at some point come to life, and it does. Look and see what. That's Talk Sport, by the way, so those stations are all playing music, so we can't play those copyright. But it does actually now appear to be working, so now we've got the problems to sort out to make it work even better, as well as clean up the cabinet, which is needs a bit of work, but we can make it do that quite easily. Now also from that, the switch from the front of there is out of circuit, but the switch on is on the back here. I'll turn the unit round. It only goes on the back here. So for that reason, this I'll left it in place so I can put the switch in the right place. I've got a switch for it, so there's no problem with that. But now we need to sort out the the aerial, as well as the putting things back into place properly and neatly, such as this here. This goes over this valve here, you see, like that. Like that, in the end. Without doing my finger in the process, and it's like back like this, you know, so it's rather
Tricky.
tricky to do, yeah. So this goes over here like that without damaging my fingers in the process. Please don't damage your fingers, thank you. Otherwise I'll be annoyed with you. The doctors will be annoyed with me. I'll leave that for now. And going underneath there, well, I'll look at the aerial circuit as well and find out from that why it's so quiet. I noticed actually looking at it that doesn't seem to be 5 live. That's interesting because 5 live is normally very strong round here, and also it seems to be more powerful at the bottom end of the band, the high frequency end of the band, which probably looks to me like it could be a capacitor. So I think, look at the circuit here. I've told the circuit up for you there, yeah. If you look at the circuit there, you see, I would look at L1, L2, and possibly R2 as well. And this circuit here, which is the AGC, goes from R2 right the way back to our line, which of course is not tied to deck on these. So it's a matter now of finding out why it's not doing what it should. Well, it is doing, but not powerfully enough. It could be the valves. I admit it could be the valves, but I personally don't think so in this case. By the way, you don't align until you sort out all the faults. Now, inside this radio, there was in fact a wire hanging loose. I don't know what it is, so we're going to find out. First of all, get your old meter. That goes to deck, and we'll see what it measures to deck. 615 ohms or so. Okay, that's it. Can you get it? 16 or 15. There you are. 615 ohms or thereabouts. 402. 607. Okay, fair enough. Right, now, earlier on, when I was checking the output valve, I found the output valve cathode circuit had a similar resistance. I just checked that and see. You see it there again. Very similar. So I wonder actually if this is the wire that goes to the cathode circuit, or one wire that does. Look at that. So that wire obviously goes to the cathode circuit. Now we know that the cathode circuit is working, otherwise we won't get anything from the radio, but we do. So I measured those two resistors and they are slightly out but not too bad, so that's okay. Therefore, that wire must be, if you look at the circuit, I just put it up there so you can see. There you are. If you look at the circuit here, it's this wire here that goes from the cathode of this valve here across to R9. Yeah, that's the way it is there. Yeah, it has to be because the resistance to the cathode of the valve is 0 and they both be the same to deck, so it has to be that valve there and there. Okay, now then, therefore it goes between R9 and C13. C13, by the way, if you look at this circuit here, I can tell you straight away it's a valve 3 cathode bypass. It's this resistor here. this one here, C13. Yeah. Now, therefore, that capacitor does not appear to be in this radio. Oh, good. Oh, such fun. So, therefore, we need to know what that wire was meant to be, and what it is basically. Now, connected to the other end of that wire should be R9, which is the load resistor for the respector diode, which again is doing something other. Otherwise, we wouldn't do anything. So therefore, if we look there like that for the volume control, again because the circuit here, you see, volume control is there. Yeah, you see it? It's there. Now from there goes to C14, and of course also goes to R9. So therefore, from the non-volume control end of C14, it should be about I think it's 200 and something 0.33 megs from there to there. Let's see if it is. It'd be better, but isn't it? Okay. There we are. So therefore we know that there is a capacitor missing from this unit. Yeah. Now also with these sets, just to let you know, get that back up again like that. The middle where the main transformer goes through R9 up here as well, and also there was the AGT as well, as you can see there. And when that's not working, the set is very, very, very insensitive, like this one is. Yeah. So there might be something on this line as well. So first thing we do is get the capacitor 25 microfarads or thereabouts. 22 will do. Doesn't have to be a high voltage because of course it's on the other end of this valve here, so it won't be carrying very much, if anything at all, quite frankly. So that has to go back in. And also of course, I notice also with this, I did look and see, there doesn't seem to be anything linked to this pin here on the first IF. Again, why I really don't know, but there doesn't seem to be anything linked to this pin here. There should be, but there isn't. So it looks as though there never was actually. Now the fact is, pin 2 of that goes straight to the AGC line here. And so if it is pin 2, which I can look on here, I think. Okay, maybe on this one here. This is where manuals do come in and do rather a lot, you know. We need to find out, it's L6 and L5. So L5 pin 2 goes to that line there, and pin 1 goes to the grid of valve 2. Now again, we know that it's working because we heard it playing, so it's not actually got anything wrong there. And we know also that there's current to V1 here. Otherwise, the oscillator wouldn't work and it won't get anything at all. So again, that wire appears to be missing as well. So first thing we'll do is get a capacitor in on the end of that to deck, and then I'll see about this here going to deck as well, pin 2. I'll measure it and make sure not to deck, but to the AGC line. Now what we do here, the AGC line goes to C7 and R2 and R8, so which one of those is easiest to get to? R8 goes after that capacitor, which I've changed on the smoothing side. After that it goes to R8. So where's R8? Where is R8? Where is R8 on this circuit? This one here. So looking like something round here. So I'll find out R8 and we'll see. I'll put that onto there like that, and we'll see if it measures anywhere at all on that line. So with it off, one end of it goes to V2, and that also goes to deck. As you can see, with the circuit here again, you see like that, you see L6, one end of it goes straight to V2 and nowhere else, also it would seem, and the other half goes to deck. So therefore V2 goes through there to, not deck, sorry, not deck, this line here, okay? So V2 is going to the first grid, of course, which is which I can find by driving through here. I think it's probably going to be let's have a look and try and find it. Which one is it? Okay, right, okay, so yeah, so that goes to there. Now that goes to there, that's okay, and nothing, it comes out of there but doesn't go anywhere else. It should, but it doesn't. The grid, of course, is the top on these, and so that might be alright. It might, because the top of these goes to that grid, so that's probably alright, that. So I'll find R8 and we'll check it. Or C7. Where's C7? Where is C7? In the middle, when it goes to deck. So, so it's the middle of these three big capacitors here. This one here. One end of it goes to deck, and one end of it goes to that capacitor there. End of it goes to deck, which is probably going to be the other end of it, which is here. But not to deck, of course. I'm getting a bit confused here. Easily done, by the way, easily done. Never get upset for that, because it's easily done. Everyone does it, even me. So there you are. So where's R2? Where's R2? Might be easy to use R2. Okay, that's over here. No, okay. Right, anyway, so R2. R2 and R8, okay, well, where's R8? Where is R8? R8, 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 R8. R7. Sometimes when looking at a circuit, by the way, we'll have this sort of problem. And again, it's something which you have to deal with as you go along. And I can't find R8 either. Yeah, I can. It's there. That's it there. Okay. And so therefore, one end of this should go to R8, shouldn't it? In fact, they both should. So from there, so from the top of there like that, it should go down. It should go down through here and to one end of R8. Let's see if it does. It does. Right, so that's okay. Phew. Right, okay, so I'll get the capacitor to put that in and we'll see what happens then. That means therefore that that is working okay, and yeah, there's another wire off here actually, so I think that's the 8-foot, so the aerial input, so I'll check that as well while I'm here. Yeah, so that goes to deck, I think. So I don't know what that is. Whenever it goes to deck, so it needs to be. I'll work that one off. Yeah. Now, therefore, this I'm looking at is R1. Now, where is R1? Where is R1? Well, there's L1 and L2. And so, and also there's capacitor C1. Where's C1? C1 or R1? Either one, doesn't matter. C1 or R1. Okay. C1 is this here. Okay. So the aerial therefore goes somewhere around C1. Okay. I know what we're doing now. Let's go and do it. With that capacitor back in, things are improving a little bit. The thing is, I can't get Radio 5 Live on it at all. That's Virgin. It comes up quite well. But if I go to the dial, I'll do this way. There is absolutely no sign of anything above Virgin. But there was Talk before, the Talk radio. Talk suppose it is now. But that's gold, of course. But now that, like I said, is possibly an alignment issue. So what I'm going to do now with that is knock it off there. Now it's time to start looking at why has it got fitted running lower than it should be, or it is basically working. Now here's the circuit again. Now, as we know, capacitors account for lots of faults in radio like this, particularly if they're not there. Of course, like now that wasn't the C14. That's back in now, in different place, because the one I put in compared to the one that I took out is much smaller. Modern components are. But if you look down here, all these here, C5, C6, D10, if they're all leaky, then they will all leak HT and RF and IF to deck. So I think the next thing we need to do is change all those, every single one of them. And of course, I might also look at the MR, the restrictor diode as well. If it's not doing what it should, then I'll put a germanium in. There's no problem that I've got those as well. So that is the next step on the road to, shall we say, recover for this. As regards the cabinet, by the way, I've got speaker grill for the front of it, and I'll clean it up. And because the top of it still got its thing off from the wall, I think I might just polish it up as much as I can and leave it looking authentic, although I will clean it. I've changed those capacitors, but it didn't have a lot of look actually. Maybe it's slightly louder, but nothing else. So what I'm doing now, I'm just going to check where it stopped working. The IF can do okay. It must do, otherwise you won't get that. So it's looking at the valve 1 stage, of course, the mix oscillator stage. Now what I'm going to do here is I'm going to put onto like that. I'm going to bunch it and slowly, hang on a minute. What I'm going to do, by the way, is I'm slowly going to inch it up and find out where it drops off, because it must do. Radio 5 Live is not off the air, by the way. I did wonder. I checked last night on tonight as well. So Radio 5 is on and running, so the station is working. And so why we don't get it on this radio and anything else above there, I don't know, quite frankly. Nobody else does either yet. It's either tuning capacitor fault, which normally creates crackle, but on this one hasn't done, or possibly the valve or something around it. Now, what happens? A mixer oscillator valve, like the one in this radio, what it does, the child part of it is the oscillator circuit, and then mixed in the pentode, hectode section of it, you see. So it is probably going to be either the valve or L3 and L4 if we're unlucky, C5, R3, C21 or C22. So we're looking now at this part of the circuit here, no other part. So that's what we're going to do. So I'm going to put this back on here if I can. These Chinese crocodile clips, by the way, they don't fit anything very well. They really don't. Try that. Here we go again with it. Right, so now of course it should come straight away. It does, and we should be able to hear the signal generator in the speaker at some point. Please. There's one. There you are. Right, okay. Now what I'm doing here is I'm working the signal generator up slowly, like that, and at some point it's going to stop. There, so it does it from there. Okay, right. Well, in that case, there's either a bent pin here, or a faulty valve, or something along those lines. So that can go off for now. That can definitely go off for now. That can come off there like that. And first of all, always check the simple, more common stuff first. Always do that. So first thing I'm going to do is check these. Check these for any problematic areas. It's common. It's very, very common. So first thing I'll do is spray the whole thing down. With the cleaner. Okay, from all angles. Long as I can. Okay, just to get rid of any muck. And then at that point, I get a piece of paper, and I'm going to use that piece of paper in each one to clean out anything that's there that shouldn't be. So I get a piece of paper, any piece of paper that's not valuable to you and can be used, and it can be used for this job. Bottled one writing paper, anything, doesn't matter. So what have we got? Everything in this trailer is useful in some way, isn't it? So now, of course, we go and we see where it's not doing what it should be doing, which is, working. So first thing we do, run the hand over it all. It doesn't feel to be catching anywhere. It feels quite open and loose actually. It really does. So I don't know quite how it's come to be doing this, but it is. Because normally you would expect to see and find a problem, but we'll go in with the paper anyway and clean out every hole, as it were, and take it from there and see if that does anything. It might not. Well, cleaning those tuning capacitors didn't make any difference whatsoever, and I found it's at the point where it goes off, and it goes off gradually as well over 100 hertz or so. So it's obviously going so far and then failing. Now, in this situation, I know straight away that the IF is getting through. We know that, and so the next thing we look at is where on the circuit it's not doing anything. Now, therefore, the circuit is here. It's the circuit, and as you know already, R4 6.8, I think 6.8. K, it is right. So from there to there, it should be 6.8 K. Let's see what it is. 7.3. Well, that wouldn't stop it running that badly, but it's not right. So anyway, from there now to, if I put that on there like that, yeah, not touching anything else, and look at the circuit here and find out it goes through L4 and it goes to one pin, I think it's pin 6 down here. So come down here and we'll look at pin 6. This, by the way, I'll put it on bleep. We shall get bleep. And we do. So we know from that resistor does need to be changed, although this part of it is working because of course it, obviously not terribly well. This part's working okay. I checked that with the meter, that's okay on the part 1 anode of the heptode section here. And so R4 needs to be changed, R6 I've changed, and also it goes through L3 and L4 to the child, to the really the child as well, from deck. Now deck is here, like that, and it goes to R3 through it to pin number about this one or that one there. So or that one, not too sure which one it is. I'll find it. If it's there, I'll find it there. What's that? What's that one? .59. Okay, well that just to check, I'll go on the end of R3 here, and it's the same. So the coil there is okay. Might want to reset it, but it's okay. C5, I don't think matches, quite frankly. It's one of these. I'll check it, but I don't think it's okay. So that resistor there, and that resistor there needs to be changed. But I think the valve is rather past its best as well. It's not the one that was in it initially, because of course the other one was the IF valve on this one. The one that was put in is an EF39, and that works with the UCH, sorry, an ECH35. So what I will do, I will get another ECH35, put that in, and we'll see if that matters. But I'll do that tomorrow because it's dark outside, and I'm afraid of triffids, you know. Well, here we are, and look what I've got here, a replacement ECH35. So in goes the replacement ECH35, the right way round preferably. And there we go. That goes on there, and that goes onto there, like that, and that goes down and round, and we hit power, and see what happens now. If it comes up, then we know that this valve has got a problem with it. I don't know what valve that is actually. So yeah, but they can respect each other. And there's 5 live. That's from further up the band. So obviously that valve has got a problem. Next thing is the RF side of it, of course. The oscillator is running. It said one of these is the here we are, right. We now have to look at the AO connectors underneath here. Now, there are 2 connections on this, one for local, one for distant, and I am going to go for the distant one because I'm a distant sort of person. So there we are. I think it's there. I think it's there. Just check and make sure. I don't think it is actually. Yeah, it is. That's there. Okay, so that goes onto there. Right, now let's see what happens now. Using the meter as an aerial, which is something which you can do. We'll see what it decides to do with us or for us with the meter as an antenna, if I can get it on. There we are. Right. So up it goes again. On its front, like that, the meter stands up and the other lead goes out the way somewhere, like that, and like that, out of the way, and I'll put it on to buses. There we are, and we try again, and we'll see what it's doing now. If this works now, and only now is the time to realign it, because we know that the thing is working properly. Be quiet. Very quickly, I'm going to change the rectifier valve in case there's a problem with the HT voltage. So I'll put another one in, a new one, an army one actually. It's got a CV number of that, and we'll see what it does now. Not much difference, was there? Okay, well I'll leave that. That, by the way, is for Andy. He's doing a set right now that needs a rectifier valve, and I think that'll do him. And for super inductance, by the way, it's on his channel. So now, therefore, we know that is wrong up to there, and we know that that is okay there, and so the only thing it can be is that capacitor, which I can take out of circuit, or the coil L1 and L2. So onto the front again, like that, and I'll go on the other side of that capacitor, which is somewhere down here. Glasses on. Let's have a look and see. Let's have a see where it is in the circuit. L1. L1, L1, L1. Right, okay. Right. A2, A1. A3 on the front, so it's is that one on top there? Is it that thing on top there? There should be a diagram somewhere at the top of this thing, which I shall also quickly look at. Here we are. Yeah, it's on the top bit. Okay, fine. Up you go. I always remember, not by the IF cams. Okay. Power back on. And we'll see if it right, well, in that case, I think the next thing we need to do let's have a quick look at the alignment, because this is looking very much like a misaligned set. The alignment on this is quite simple. You don't have to go directly onto the set, something like this. You just go nearby and it'll pick it up quite well. So away from the station, like that, unplug, and I'll go and switch the generator on. Turning up full for now, and like that, and we'll see, and we'll try and find out where it should be. It should be 460 kilohertz on this, by the way. So generator tuned to 460. There we are. That's broad, that's very broad, isn't it? So that's 460 there. And so now we look at the IF cans and find out where it's off. Alignment is off on this radio for a very simple reason. It didn't seem to need it. When I looked under the chassis, look at the other side of these two here, I found a very bad dry joint, and on nudging it slightly it came off. Put it back on again, and everything came back to where it should be. As you can hear.
To ask him what it was all about.
So there you are.
But obviously if there's a concussion situation, then that can be...
So now I'm going to change the lead here. Sort this out here. I've taken this off as well, by the way. I'm going to go over it with the rubber and make it look better. This I'm going to put it where at the other end, so it won't look as bad. And then this of course goes on here. But now really it's all very much you know, stuff that makes it look presentable. The hole in the front, by the way, what I'm going to do here is I'm going to get some wood varnish of some kind, mix it with sawdust from inside and fill that hole up and leave it to dry. It won't be perfect, but it will do. There's no back with this. So if anyone's got one, then I'd be more than interested. But as you can hear, the radio itself is fine and working and dandy. So like I said, it came to me not working at any bits and bits missing, but now it's working pretty well. Also, by the way, a lot of capacitors I changed on it, maybe I didn't need to. Always fault find before that capacitor changing, without fail. This set doesn't have the grid cap voltage on one end like many sets do, because it's a short superhead. But that is one which you must change. But the rest of them, leave it and find all the faults and then do a recap and everything else. But don't ever just change all the capacitor on spec. It doesn't work, and you get yourself in a more bigger mess if you do. Right, it's trick time now, because of course handy tricks are always worth knowing. And with these, the tuning control works again, as you can see. Bring it up there, yeah?
I think.
As you can see. Like that. And in this case, we actually had it working. In an interesting way. You see, with these, there's a tuning string that goes between the tuning capacitor back here. There's a thing for it to go down to here, and the string goes from here to there, here to there. What I've done with it being so short, with it being so loose, I've actually put on a sort of a drive belt. I say a sort of drive belt because what it is actually is it's a rubber from sealing part of the rubber, and it's just the right size to work and do that. So actually at the moment the tuning is done rather differently. So now this has to go back on, and the cabinet, well, that's nearly done as well. But one more thing to do on that, well, two actually, because I want some new material on here, the base, some new material on there, which is coming, and of course the hole on the front, because I put a new cable on this as well, and the switch is now once again on the back where it should be. Right round the back, not the front where I put it. The reason why we put it in the back was with it here, the mains would be very close to here, the tuning capacitor, and it could hum like buggery. So I'll put it back where it was meant to be. So now this slot here is as good as done. This slot here is as good as done. So now it's the cabin to sort out as well. And then of course we've got a working radio again. Well, we've got that already, you know, but there you go. So it came in pieces and it's now in one piece again. Right, this is the case redone. There's a light behind it, as you can see. So you see the speaker is not in yet. But what I've done, I've painted it nearest colour I could find. Doesn't look too bad, but I might possibly in the future change it to another colour. There you are. And of course, a quick trip to Hobbycraft works wonders, it really does. I got a 2 metre square roll like of this stuff, and it looked pretty good on radios. It looked a little bit lighter, but you know that, you know, maybe when it was new they did look like that. I don't know. It's possible, of course, because you know you're talking 80 years old, me. So far what I've done is, for the record, painted it, put that on and put it in the case in the place of what was there. It's not quite right, but it'll do. Loose as well, so it won't obstruct the sound from the speaker in any way, shape or form. So next thing we have to do is put the speaker and the set in the case. Again, the speaker just goes on the back, and then the rest of it here goes in and screws into place. At that point, we put the knobs on, put the screws in, and that's it. It's done. And here we are with a working radio receiver again.
Possession in the game, but Tim Krul just had one of those days. Made some
live.
Coming forward over the
Top
half.
Sport. Virgin. And such like.
Losing the match.
That is on a very short aerial, that, by the way, so it's quite sensitive. But there you are. So what have we done with this? Well, first of all, tuning dial had to be restrung, which I did actually with the belt, because it's such a short. You can do that. So put a belt in there. Tuning capacitor is okay. Milling capacitors weren't, but again, do be careful, by the way, because whatever doesn't go to deck, it goes to transform. It goes to 80 negative. Watch out for that one, because otherwise the set will hum and you won't know why. Well, the capacitor that I changed, maybe I didn't need to, I don't know, but again, capacity changing isn't something which you have to do on a radio by any stretch of imagination. You don't have to do it, no matter what people say. So there you are, the working radio.
Slightly undercooked.
And it could now work for another 80 years probably, you know.
You're listening to Brighton.
I'm not going to back for it, by the way. I might get one at Gorbon tomorrow, but the paint job looks okay. I've filled in the hole on the front there, and so it looks a lot more respectable compared to what it did. So
Now fourth.
this is Steve. It's Steve Longstay Workshop saying, take care of yourselves and remember, keep fixing radios. And I'll see you soon. Bye bye.
Nick, I think off the heel.